presentation from Uponor in just 30 seconds, so stay tuned. Wanted to make sure everybody got settled in. Welcome to today's special presentation from Uponor. Did you know that April is National Rebuilding Month? With the use of proper fire sprinkler design, we're hoping to do a lot less rebuilding after a residential fire. And to help us learn more about the expanding fire sprinkler mandates for new construction across the country, we have Melisa Rodriguez with us. She is the Design Services Supervisor for Fire Safety at Uponor. She's a professional engineer with over 10 years experience in the industry, with a NICET Level 4 certification in fire sprinkler design. She received her bachelor's degree in mechanical engineering from the University of Minnesota and is a professional member of the National Fire Sprinkler Association, the National Fire Protection Association, and the American Fire Sprinkler Association. Melisa is also the Vice Chair of the Communications Subcommittee for the National Fire Sprinkler Association's Future Leadership Committee, an alternate member of the National Fire Protection Association's Residential Technical Committee, and the alternate liaison to the Governor's Council for Fire Prevention for the Minnesota Society of Fire Protection Engineers. Now, if you have any questions during the course of today's presentation, you can submit those for our guest by using the questions box on the right side of your screen. I'll review those questions and pose them to Melisa during the Q&A time set aside after her presentation. Melisa, welcome to the program.
Thank you, and welcome to today's webinar about what builders need to know about residential sprinkler design. I'm Melisa, and don't really have a whole lot to add after that introduction, so we'll just get right started. Today we're going to talk about a brief history of residential sprinkler systems and the standards that govern them. Then we're going to go into ways you can add value and reduce costs as a builder by going over underground supplies, builder techniques to save on costs, design techniques, and different system options. Historically, fewer than 2% of homes have had fire sprinklers installed. However, in more recent months, that number is getting a little closer to 5%. The International Code Council voted to mandate fire sprinklers in the 2009 International Residential Code. This has been effective since January 1 of 2011. State and municipalities are adopting this mandate at their own pace. Currently, California and Maryland require sprinklers in all new 1- and 2-family homes. And other municipalities and states are adopting them on their own timeline. Minnesota actually just added their mandate for all new homes over 4,500 square feet. NFPA is the international recognized developer of standards for the fire protection or fire sprinkler and electrical industries. NFPA 13 was developed in 1896, and it is the standard that covers commercial designs and installations, as well as high-rise residential applications. NFPA 13 is the foundation for the two residential-specific standards, 13R and 13D. 13R is the standard that governs multifamily residential buildings up to 4 stories in height. This includes hotels and apartment buildings and is a combination typically of residential and commercial space. It was developed in 1989, and in this type of system, tenants will all share the same piping system. 13D was developed by a subcommittee in 1973 and adopted in 1975. The purpose of 13D is to improve the chances for escape or evacuation of the tenants in the home. This is done by preventing flashover. Flashover occurs when ceiling temperatures reach 1100 to 1500 degrees Fahrenheit. At that time, the smoky layer that has developed in the room will ignite, and all combustible surfaces in the room combust at the same time. Flashover can occur in as little as 5 minutes. Jumping right into how you can add value by including a sprinkler system and reduce the costs that will be added by that sprinkler system. The first thing we need to look at is what actually adds costs to the sprinkler system. Sprinkler heads tend to be one of the most expensive components in the sprinkler system, so keeping the number of sprinklers low will keep costs low as well. Pressure losses can greatly impact the cost of the sprinkler system, as restrictive pressure and inadequate pressure could mean costly tanks and pumps to supply what is required for a sprinkler system. Additionally, the installation time is a large factor, as labor costs are a big cost driver, and systems that are easier to install will save on time and money. To begin understanding how fire sprinklers are sized and calculated, we start with the requirements for pressure and flow at each sprinkler head. The minimum flow required is given in 13D and is 13 gallons per minute and 7 psi for most standard residential sprinkler systems. The 7 psi requirement is the minimum allowed pressure. However, low flow sprinkler options do exist, but you will be limited in your allowed spacing to no more than 14 feet between sprinklers and 7 feet off of a wall. Based off of the minimum flow required in 13D of a typical 13 gallons per minute, and the fact that 13D requires us to calculate the maximum of 2 sprinklers that are the most hydraulically demanding, you'll find that the flow required for most typical sprinkler systems is 26 gallons per minute. For sprinklers at this flow, the spacing is 16 feet from sprinkler head to sprinkler head. 13 requires you to perform hydraulic calculations using the Hazen-Williams equation, which is shown here. This formula gives you a pressure loss per foot of pipe based on the flow, internal diameter of the pipe, and the roughness of the pipe walls. This shows that smaller pipe sizes will mean more friction loss, and higher flows also mean higher friction loss. So how can costs be kept to a minimum? Knowing your water supply options is important. Maximizing the allowable sprinkler omissions when designing a home will save on the number of sprinklers. Additionally, there are options your design professional can choose to keep pressure requirements low. We'll start by discussing water supply issues. When considering a new development with fire sprinklers, it's very important to verify the size and distance of the supply line to the structure. The supply line determines how much money any given sprinkler system is going to cost the sprinkler installer, builder, and eventually the homeowner. Large underground supply lines to houses mean smaller and easier to handle sprinkler lines. Not only are smaller lines in the structure more cost-effective from a purchasing standpoint and less expensive from an installation standpoint, smaller lines create fewer conflicts during installation. This means fewer change orders and more money in the home builder's pocket. Unfortunately, in most cases, supply lines are likely already conceived of, paid for, and installed before sprinklers are on anybody's radar. It is in the best interest of the builder to have a sprinkler design completed before supply lines are in place. This way, the builder can give the designer the specifics regarding the underground distances and allow the technician or engineer to determine which pipe size will work best to provide for a smaller system. This is the best way to avoid unnecessary pumps, large lines, and conflicts with other trades. It can be possible to size the underground supply without completing a full design, as an experienced sprinkler designer will understand the pressures typically required at the house for standard sprinkler systems. Shown here is a standard underground supply detail. It shows the distances from the street to the meter and the meter to the house, as well as the valves and fittings that would be installed in the underground supply line. Shown here, you can see that at 26 gallons per minute, you lose about 10 pounds through the 46 feet of 1-inch copper. A 1-inch meter will lose 3 pounds at 26 gallons per minute, and then you lose another 5 pounds through the 23 extra feet from the meter to the house. This system includes a pressure-reducing valve, and this particular make and model of pressure-reducing valve loses 7 pounds. The total pressure loss through the underground is 25 psi. Since we have a static pressure of 80 to start with, this means you are left with approximately 55 psi at your shutoff valve. This is typically more than adequate for most standard sprinkler systems. Now we'll look at what will happen if we just change a few things in the underground supply. In this scenario, we have, instead of 1-inch, we have 3/4-inch copper from the city main to the meter. You can see that this increases the pressure loss through that segment of pipe from 10 all the way to almost 39 pounds. Additionally, we are using a 3/4-inch instead of a 1-inch meter, and a 3/4-inch meter is required to have 14 pounds of loss in the hydraulic calculations from 13D. Additionally, this has a different make and model of a pressure-reducing valve and loses 17 pounds at the same flow that the other pressure-reducing valve only lost 7. The total pressure loss in this scenario is over 75 pounds, which means you have just over 4 pounds remaining at the house. This is not even enough pressure to operate a single sprinkler. Shown here are some of the common types of pipe used in underground supplies. You can see that the 1-inch polyethylene pipe will lose twice the pressure that is lost through the same length of 1-inch PVC. Looking at numbers from the same type of pipe, you can see that the difference between 3/4 inch and 1-inch copper is quite significant, losing over 4 times more pressure at the same flow. Additionally, over time, steel and copper supplies can have reductions in their pipe internal diameter due to things like corrosion. In some cases, duplex or dwelling units will share a common supply line. In this case, the standard requires we add an additional 5 GPM from the point where the supply line is shared back to the street. In cases like this, it's even more important to be aware of the additional flow requirements and the additional friction loss that will occur through that shared supply pipe. I mentioned the differences between different pressure-reducing valves that are available. You need to make sure that you are aware of what the loss through your pressure-reducing valve is. Shown here is a typical pressure-reducing valve that's commonly used. You can see that a 1-inch valve at a 26 gallon per minute flow loses 17 pounds of pressure. Now we look at a different make and model of pressure-reducing valve. Again, it's a 1-inch valve, and at 26 gallons per minute, the loss is only 7 pounds. Understanding these differences from the beginning and making that part of your choice when you're choosing a pressure-reducing valve can have a very large impact on available pressure and cost. Many jurisdictions have standard meters that are specified and installed by the local water department. The size of the meter could potentially have a significant impact on available flow and pressure to the system. 1-inch and 3/4 inch meters are almost always capable of providing the flow required for a standard sprinkler system. A 1-inch meter is rated to flow up to 50 gallons per minute and has very low pressure losses. However, many water departments will charge a significant fee to install a 1-inch meter due to perceived inefficiencies. 3/4 inch meters are more typical and are rated up to 30 gallons per minute, which is usually above the total flow requirement for a standard sprinkler system. 13D requires a loss of 14 psi through a 3/4 inch meter. Where we run into difficulties are where the meter is a 5/8 or a 3/4 by 5/8 meter. These meters are only rated to a flow of 20 gallons per minute. 13D does allow for the use of such meters at flows beyond their rating and include pressure losses that should be used in the hydraulic calculations. However, there still may be liability concerns as the meter manufacturer does not provide any data or support for meters that are used beyond their maximum rated flows. So you should always try to keep your meter selection typical throughout a development. If you're putting sprinklers in and you can size to worst case scenario, this will limit the amount of communication that is needed to coordinate supply line sizes with your sprinkler contractor. An additional way to save on the pressure loss in your hydraulic calculations is to identify the make and model to your sprinkler design technician. As you can see, 13D requires a loss of 14 pounds for a 3/4 inch meter at 26 gallons per minute. However, if you know the make and model of the meter, you can often reduce that loss by using their published specifications. Shown here is a standard meter that at flowing 26 gallons per minute loses only 6 pounds. It is also important to find out if your local water purveyor installs restrictive meter setters at the meter. The valves and fittings used in most meter setters are extremely flow restrictive. If this information is not included in the design, the system will not perform as expected. In fact, it may not even be possible to flow the required amount for a standard sprinkler system through a meter setter. Elevation changes are another important piece of information that need to be provided for the design technician. Elevation change loses or gains 0.43 pounds per foot of elevation. This means that if the home is above the site of the pressure reading, the pressure loss must be accounted for in the hydraulic calculations. If a pressure reading is taken at the bottom of a hill and you get a static pressure of 60 psi, even a 20-foot difference of the actual house location means over 8.5 pounds of pressure loss due to that elevation change. So what can we learn from this information on underground supplies? We know that it's important to talk to your water department early on in the planning process and involve your design professional if possible. You must find out accurate, available pressure and water supply information to ensure that the hydraulic calculations will be accurate for your system. If you have the option to choose a supply line, talk to your design professional and they can help you size what would be an appropriate way to supply your sprinkler system in a manner that will keep your pipe sizes inside the house small. It's important to know what make and model of your meter and pressure reducing valve are so that the most accurate information can be used in the hydraulic calculations. Additionally, any other fittings, valves, or pressure restrictive devices must be known before the design is started. There are techniques that builders can take advantage of to help reduce the actual number of sprinklers that have to go into the house. Sprinklers are allowed to be omitted from 13 areas per NFPA 13D. Maximizing these omissions can save money by reducing the number of sprinklers. These areas include closets, bathrooms, ceiling pockets, non-accessible concealed spaces, and locations that have fuel-fired equipment. Additionally, slopes and beams can create complications for sprinklers and can drastically increase the number of sprinklers needed due to the obstructions caused by these features. Pockets that are created by decorative beams could potentially need a sprinkler located in each pocket, and false beams may be able to have sprinklers installed at the bottom as long as certain requirements are met, such as no deeper than 8 inches down from the ceiling. Sidewalls may also be a good option when these obstructions are seen in a house. Sidewalls can be installed as low as 12 inches below a ceiling. So where are these omissions allowed? Sprinklers are not required in garages, open attached porches, carports, or similar structures. However, you should always check with your local AHJ for requirements above and beyond 13D. California currently requires full sprinkler coverage in all attached garages and detached garages that have living space above. Sprinklers are not required in closets that are smaller than 24 square feet and where the shortest dimension does not exceed 3 feet. This might sound a little bit confusing. However, shown here is an example of a closet that is under 24 square feet and the smaller of the two dimensions does not exceed 3 feet. As soon as you exceed that 3 feet, this closet, which is still under 24 square feet, now requires a sprinkler. You can see here 3 examples of closets and where they would or would not require a sprinkler. On the top left, you see a sprinkler or a sprinkler closet that is only 12.6 square feet. This is because the smaller of the two dimensions is again over 3 feet. The closet to the right is only 15 square feet and the smaller dimension is exactly 3 feet. A sprinkler would not be required in this closet. On the bottom, we see a closet that is over 24 square feet and requires a sprinkler. The way that a builder can take advantage of these omissions is to, if you are designing and laying out your house, and you can choose to keep your closet dimensions within the limitations that allow sprinklers to be omitted, you can save on sprinklers. Sprinklers are also not required in bathrooms that are 55 square feet or less. According to the definition of a bathroom, it is a room or compartment that contains a sink, a toilet, or a tub. This means that in the case shown here, the room to the side that shows the toilet is actually its own compartment. If it's under 55 square feet, it does not require a sprinkler. Shown here are 2 examples of potential bathroom arrangements. On the left, you see a bathroom that is split into two separate compartments, one containing a toilet and a tub, the other just a lavatory. If that wall were removed, that bathroom would now be over 55 square feet and would require a sprinkler, where the wall would have split it into two compartments, both under 55 square feet. Additionally, sprinklers are not required to be installed in ceiling pockets that are less than 100 cubic feet, as long as the sprinklers on the lower portion of the ceiling completely cover the floor space. You can take advantage of this rule by limiting the size of pockets created, total pockets in a room, to less than 100 cubic feet. Additionally, sprinklers are not required in attics, whether they are with or without storage, penthouse equipment rooms, elevator machine rooms, and other concealed spaces that are exclusively for dwelling unit ventilation equipment, crawl spaces, any other concealed spaces that are not intended for living purposes. However, if fuel-fired equipment is present in these spaces, it may be necessary to install a sprinkler above the fuel-fired equipment. In the most recent edition of the code, if that fuel-fired equipment is above all living space, a sprinkler is not required. If it is on the same level or below, you do need to provide a sprinkler over the fuel-fired equipment. The only instance where a sprinkler would not be required would be if that fuel-fired equipment were in a closet that is only open to the garage or the exterior of the home, and there are no penetrations that are unprotected directly into the dwelling unit. So if your furnace or your water heater is in the garage or in a closet in the garage, you do not need to protect that fuel-fired equipment with a sprinkler. Finally, there are steps that can be taken during the design process that can keep the pressure requirements low and reduce the total number of sprinklers required. These techniques include the material selected for the sprinkler system. Some materials may have compatibility or liability issues, and if exposed pipe is required, those applications can get costly. The piping configuration chosen by the design professional can impact pipe sizes and pressure required for the system. Additionally, the type of system chosen can impact costs and pressure requirements. Standalone systems typically require additional valves and riser components, where multi-purpose systems do not require anything more than the main shutoff valve, because cold water plumbing and fire sprinkler systems are integrated. When selecting the material specified in the sprinkler system, the pros and cons of each type of pipe should be taken into account. CPVC systems use inexpensive material with large internal diameters and have 175 PSI rating. They do have a limited exposed listing. However, compatibility and liability issues are increasing for CPVC. Copper also has large internal diameters, and can be installed in exposed applications. However, the material is expensive and can be prone to pitting, scaling, or corrosion. Steel is similar to copper with its larger internal diameters and exposed applications. However, it is also a more expensive material and is prone to corrosion and has compatibility issues with potable portions of residential systems. Uponor Aquapex is a flexible pipe that utilizes fewer connections, does not require any glues or chemicals, and is resistant to damage from freezing. They do have smaller internal diameters. However, the sprinkler, the pipe and the fittings have a 25-year warranty. When comparing PEX versus a CPVC system, or really any rigid pipe system, you see that the options are very obvious. PEX is flexible and easier to work with. Again, there are fewer fittings, which reduce potential leak point liability. It is not possible to dry fit a PEX system, and there are no solvents or toxic chemicals. Connections would not be affected by rain or high humidity conditions, and it expands up to 3 times its initial diameter, which minimizes the potential for freeze damage. You see here on the right that 10 connections would be required to feed this sprinkler in a CPVC system, where only 2 connections are required for a PEX system. Shown here are the impact that changes to the system can have on rigid pipe versus flexible pipe systems. Shown here is a rigid pipe system, specifically CPVC. It has a 1-inch riser and branch lines and shown here is a two-head calculation. The demand at the street is 50.8 psi. Changes that have to be made to offset conflicts in the field can require additional fittings be installed in the line. Shown here is the original layout of the sprinklers and piping. And on the next slide, you will see the addition of 4 elbows to offset around an obstruction in the field. These 4 elbows increase the sprinkler demand to 58.4 psi, a full 7.6 pounds higher than the initial demand. Now we look at the impact that changes have on a flexible pipe system. Shown here is an Uponor Aquapex system, again with 1-inch riser and branch lines and a two-head calculation. The underground supply information is the same, and you can see that the demand for this system at the street is 52.5 psi. Now we look at what would happen if we had to move ahead due to an obstruction in the field. You can see here the initial layout of the sprinklers, and here a sprinkler that had to be moved. There were no additional fittings added, and the new demand for this new layout is only 0.1 psi higher than the initial demand. When looking at your different system options, you should understand the different types of arrangements of the pipe. Loop and tree systems are typically what is installed for residential systems. The pros of a loop system include uniform pipe sizing, the ability to make minor changes in the field that don't affect your hydraulics significantly. You can use smaller pipe sizes, and you can count on water circulation throughout your sprinkler system. Some cons of a loop system would be that you have slightly more pipe installed. The calculations will be more complicated, and you would not be able to use the prescriptive pipe sizing method that is available in 13D, which allows you to calculate a sprinkler system without computer software. The pros of a tree system are the ability to install less pipe, to use the prescriptive pipe sizing method, and the hydraulics from a computer software program would be much easier to follow. However, for a tree system, you're likely looking at larger pipe sizes, a variety of pipe sizes. You'll have stagnant water, and changes will have a much larger impact on your system. Additionally, you would be looking at the difference between standalone or multi-purpose systems. Standalone systems are historically associated with tree piping configurations. Shown here, you see a standalone system and the typical riser assembly for a standalone system. They usually require a backflow prevention device to keep water from flowing back into the potable water. They also require additional drain and test connections. A multi-purpose sprinkler system combines the cold water plumbing fixtures and the fire sprinkler piping, and they are typically seen as looped systems. This configuration will help reduce stagnant water in your sprinkler lines. Shown on the next slide, you'll see a typical riser for a multi-purpose system. As you can see, it is simply the main shutoff valve and the warning sign. No additional valves or fittings are required for a multi-purpose system, as your test and drain devices are in fact your cold water plumbing fixtures. There are techniques that can be used by a design professional that will limit the pressure required for the sprinkler system. Limiting the use of sprinklers spaced beyond 16 feet will keep the required flow and subsequent pressure losses due to friction lower. However, it can be useful to use the sprinklers at their available spacing beyond 16 feet when they are limited to a single sprinkler within a compartment. This is true because only 2 sprinklers within the same compartment are required to be calculated together. The flow required for sprinkler spaced at, for example, 18 feet is typically 17 or 18 gallons per minute. As an example, you can see here a bedroom that has a ceiling fan located in the middle. Sprinklers are required to be located at least 3 feet away from ceiling fans due to the obstruction caused by the housing. You can see that a 16-foot spaced sprinkler will not work in this situation because in order to be no more than 8 feet off of a wall, we are too close to the ceiling fan. In this situation, you might think that 2 sprinklers spaced at 16 feet would be the solution. However, you can see that if we go with 1 sprinkler spaced at 18 feet, we can be 9 feet off of a wall and not be too close to the ceiling fan. This and other techniques are used by a competent design professional to keep the required number of sprinklers low. Uponor's Design Services Department is staffed with experienced and certified design technicians who can help answer any questions and will always try their best to keep your costs at a minimum. That will conclude my webinar for today, and I think we can open it up to any questions.
Thank you, Melissa. We really appreciate that. And yes, we do encourage people to send in their questions with the Q&A box or the questions box on the right side of the screen. While we look for some of those, I did have a couple of my own questions and understand that I don't know nearly as much about these systems as you do, Melissa. In a multifamily setting, is it possible to combine a recirc system with a sprinkler system, or do the 2 systems have to be separate?
I mean, the recirc system for the plumbing fixtures could theoretically be combined with the multi-purpose sprinklers. It would not be in the same traditional setup. It would be an unusual arrangement. It's not something we see often. So you would still be able to install all of your hot water piping in a standard arrangement, and it would just be the cold water fixtures that are coming off of your sprinkler piping.
Okay. We do have a question from Edward. He wanted to know, can you exceed the 8-inch rule, or is that the 8-foot rule? It's my type's a little bit small. Can you exceed that rule?
If he's talking about 8 foot as far as maximum distance from a wall, if it was shown in the last slide, sprinklers are allowed to be spaced at up to 20 by 20 for most residential sprinklers. However, you have to make sure you're calculating for the increased pressure and flow in order to get those sprinklers to spray at that distance.
Okay. Had a couple questions from people wanting to know, can they get a PDF of this presentation or any kind of hard copy? I know certainly that a recording of this webinar will be on the archive section of Green Builder Media website, but what about any kind of hard copy or PDF of this?
Yeah, I think we can provide that for anybody that might need it.
Okay. If you would like something like that, please send in your email address in the question box. We can collect those, and then we'll pass those along to Uponor. Had a question from Steve. He wanted to know. Steve wants to know: is there a typical or ballpark cost per square foot for a residential system?
Well, unfortunately, the number that's typically given is anywhere between $1 and $2 per square foot. The variation is because of a number of factors. Geographical location has an impact on the cost. Availability of experienced installers also has an impact. And you can look at 2 homes that are the same size. One of them could need 20% more sprinklers than the other, simply because of the different room dimensions. But, I mean, I think the national average, last I remembered, it was somewhere around $1.60. It could be a little lower, but like I said, that the variation can be anywhere between $1 and $2.
Okay. Mark had a question. Can you talk about testing, especially in regards to the bucket testing of sprinkler heads, and when that requirement might be necessary?
Well, if you actually look at the requirements in the standard, no flow testing is required. They simply say that the system has to be able to withstand standard operating pressure. The verification of system performance is meant to be provided by the hydraulic calculations. However, Uponor does require a single head flow test at the conclusion of an install. This would typically happen after the piping and obviously the sprinkler heads are installed, but you would not install that final sprinkler. You would instead use the flow test assembly that is shown in on Uponor's details page or in our flow test instruction document. Obviously, it might be useful to conduct this flow test before the house is sheetrocked or finished. And ideally, the flow test would be performed in the presence of your inspector or plan reviewer or AHJ so they can verify the system performance. Again, it's not a requirement, but it's always a good idea.
Okay. Edward wanted to know if the CPVC in garages needs to be protected.
CPVC has a limited exposed listing. It's actually, as far as I know, only allowed in basements that meet certain requirements as far as the construction type, joist spacing, and different things like that. CPVC installed in garages would need to be protected with a fire-rated barrier.
Okay. Johnny would like to know if there are any NICET requirements or specific certifications required for installers.
The installers need to have whatever license would be required for sprinkler and system install. Whatever that is going to be mandated by their local jurisdiction. Some jurisdictions, obviously for multi-purpose systems, they will require that you have a plumbing license, and others have specific licenses only for 13D systems. Some jurisdictions require you to take further training to be certified to install sprinkler systems. The NICET certifications are only required on the design side. That doesn't mean an installer could potentially do their own designs, but in most states, a NICET level 3 certification is required as a minimum. In other states, however, that level 3 requirement is not enough, and they will sometimes require that a professional engineer review and stamp the plans.
Okay. Stephen's got a question about wells. What would be the least amount of gallons per minute output if you're using a well?
So the 26 gallons per minute that I kind of covered throughout most of the presentation is for a standard sprinkler system. For standard spray residential sprinkler heads, that's the minimum flow that is required from any of those sprinklers. However, I did mention that there are low flow sprinklers. These have smaller orifices and require less gallons per minute, and then typically what that equates to is a higher pressure demand. You can get low flow sprinklers will go as low as 8 gallons per minute per sprinkler. However, then you would be limited to no more than 12 feet between sprinklers and 6 feet off a wall. So yeah, low flow sprinklers are an option when GPM is limited. However, you will find it will increase the number of sprinklers required in most cases.
Okay. And Correa kind of asked the same question about supply to a rural house and a well system. Would you need a second well or a deeper or bigger well? I think it kind of covered that, but is there anything additional you need to add on that?
No, that's actually a really good question. You know, a lot of people think that a well system would mean you have to have a storage tank and a pump, and that might be true if you're looking at a system where, you know, the well is already in place. You know, they're not going to, you know, be able to upsize the well if the well doesn't have enough stored water, and if the well pump isn't large enough to supply the sprinkler system, then you would likely need to have a supplementary storage tank and pump to supply the sprinkler system. However, if you know early enough in your planning process that you're going to need a sprinkler system and you know it's going to be fed off of a well, your design professional can actually aid in sizing the well pump, and the pipe that goes to that well pump. It is possible to supply a sprinkler system from a well in a rural setting.
Okay. I certainly want to encourage people to continue to send in their questions using the question box. We're going to keep going with Deborah's question. Is it advisable to install a system when a home's only source of water is rain collection?
The requirement for stored water is that you have a 10-minute duration. So if a home is only using a rain collection system, they would have to have a storage tank that could hold enough for a 10-minute duration. For a sprinkler system that flows 26 gallons per minute, you would need to have at least 260 gallons of water available at all times. Then when your sprinkler system would operate, you would then have enough water to supply, again, a full 10-minute duration.
Okay. And, you know, on that flow rate and the amount of water, I had a question about that. A lot of times, you know, people are concerned about water damage post-fire. Obviously, fire is tragic in and of itself, but now you get water damage. Can you give us a comparison of the flow rate of a sprinkler system versus a fire hose, and subsequently the average amount of water used by each in the event of a fire?
It was funny. I remember that our own Eric Scari in his webinar had those numbers. In a typical sprinkler fire, one sprinkler is going to operate and put out 13 gallons per minute. So if you think about a 10-minute duration, you'll see, 130 gallons will be put out on that fire. If there are no sprinklers and the fire department is required to respond and attempt to put the fire out, a fire hose is going to be putting out 250 gallons per minute. As far as the total amount of water used, again, it depends on how long it can take. I know there are numbers on the average amount of water required to control a fire from a fire truck, but I don't have that number in front of me. But like I said, you're looking at 250 gallons per minute versus 13. So obviously a very significant difference.
Sure, yeah. And you referenced Eric Scari's webinar. I believe that is also in the archives from Green Building Media's website. Another great resource to access for people who have interest in this topic. I want to continue on with Jeffrey's question. Is there a PEX pipe that is rated for exposed fire conditions?
That is something that is definitely in the works for Uponor. We will be very excited to have an exposed listing, hopefully in the near future, but that is currently not something that we have.
Okay. I want to stay on PEX for just a minute. Correa, and I hope I'm pronouncing that name right, asks, because PEX pipe has the ability to expand up to 3 times the original size, wouldn't that drastically change the design of the system?
That expansion is really only going to occur under extreme pressure situations. So, we say that it can expand that much and still reduce back down to its initial size. This is obviously very beneficial for situations where you might have a freeze-up in your system. PEX does expand and contract with changes in temperature, but it's not going to be of a significant enough amount to impact your hydraulic calculations.
Okay. Wanted to get to a question from Stephen. He's asking about 13D, and does it require an alternative energy source for the well in the case of a power loss?
There are not any requirements for an alternative power source when there's any type of electrical components in the system. This does mean, as some people will have concern about, in the event of a power loss and a fire, if you have a pump or any other electrical components supplying your sprinkler system, you may not have water to your sprinklers. And that actually is just a reality of sprinkler systems in general. Hopefully, if you're concerned, then I would definitely recommend a backup power source.
Okay. Barry's got a question going back to the topic of rural wells. Most tanks lose pressure with a power loss. Is a pressure tank required?
Pressure tanks may be useful to supplement a water supply that is maybe not providing an adequate flow to the system. When we talk about a storage tank, we don't necessarily mean a pressurized tank. You could have an open-air storage tank that is filled from the well or whichever water source. One scenario is a storage tank with a float valve that would refill as soon as the water got below a certain level. In fact, in those scenarios, you can decrease the size of your tank because you can look at the refill rate and subtract that from your 10-minute required duration of supply. So as far as using a pressurized tank, like I said, there are scenarios where we have completed designs that have pressure tanks. It's typically only for a supplementary. It won't provide the full storage and pressure requirements for the sprinkler system.
Okay. Wanted to certainly thank everybody for sending their great questions, and please keep them coming in. I had another question, and again, this is out of ignorance of the systems. I'm assuming there are sensors that target the water usage to the fire area, and I thought of this question when you were talking about the closet requirements. If you get a fire in the kitchen, closet's on the other side of the house, it's not like the entire system turns on, right?
Right. Since the sprinklers are individually heat activated, only the sprinkler that is in the presence of the fire and thus the heat is going to go off. There are actually no types of sprinklers that are in any way wired to any kind of a sensor that would trigger them all to go off at the same time.
Gotcha. Okay. That's what I thought. I just wanted to make sure it was clear. Got a question from Jean. Jean wants to know if a homeowner can modify a combination system in order to add a toilet and sink.
The addition of plumbing fixtures to a multi-purpose system will generally not have a large impact. However, any changes to the system should be looked at by a design professional just to ensure that they are not going to have a negative impact on the performance of your sprinkler system.
Wanted to make the last call for questions. We've certainly got a lot of emails that have come in looking for a copy of this presentation, so really appreciate everybody sending those in. Last call for questions from the audience. I have one myself. Are there risks in installing an underground system in a seismic area? And if there are risks, what's the recommendation just to kind of minimize those?
So by underground you mean in a basement below grade?
Yeah.
You know, there are really no allowances that need to be taken in 13D for earthquake or bracing of pipe. I mean, you know, we look at issues like that for commercial systems, and it's covered extensively by NFPA 13. You would probably have cause for concern for rigid pipe systems. However, if you were using a flexible pipe system, I really can't see anything that would be damaged by an earthquake, even if it were installed below grade in a basement.
And I didn't think there were really too many risks, but I knew obviously there are areas in the country where seismic is a very big concern, and they do conduct below grade construction. So I just wanted to make sure we checked that off as far as, you know, understanding how that all works. I don't see any other questions at this time. I very much appreciate, Melissa, you coming on and sharing your time, your knowledge with us today. I certainly want to thank our attendees, the great questions that they've got, the emails they're sending in to get the copy of the presentation. You're going to have a huge list of people to contact, Melissa, and you're probably very appreciative of that.
Yes, I am, Mike. Thank you.
Well, I, again, want to thank everyone for attending, Melissa for her time. This webinar will be available in Green Builder Media's archives later this week. Until next time, take care, everyone. Bye-bye.